Canada is a very important market to Becker Underwood, as you've kind of discussed to us today. We've got soybeans, we've got peas, we've got lentils, chickpeas, growing faba bean market. When you see Canada, what do you see in terms of Becker Underwood's perspective?
Yeah, that's a great question, because historically, our business is pretty well known in Canada, I would say, amongst growers and the supply chain. But we've been really heavily focused on providing products for legume markets. So in Eastern Canada, soybeans, and in Western Canada, the pulses. And a big drive for us in our BioStack program is to extend the crops that our products can be applied to. So we're now selling products, for instance, on canola, very important crop in Canada, as everybody knows. I think I hear 21 million acres this year. Very important crop. Wheat also, So at the heart of our development and our kind of hopes and aspirations for Canada is that we can apply our products across a much broader range of agricultural crops, and we also extend and expand into more specialist turf and ornamental kinds of crops. I think our products lend themselves to that kind of diversification.
So Peter, a lot of discussion today about biologicals complementing the current seed treatment business that we have in Canada and in the U.S. Why do you think the biologicals play such a key role in the future of seed treatments?
Well, fundamentally, the reason is that all plants, wherever they grow in the world, whether they're crop plants or ornamentals or weeds, they depend on their interactions with biologicals to thrive and survive. And so at the heart of our BioStack strategy is, can we harness that power of those biologicals, and can we differentiate between those which are helpful to the plant, those which are harmful to the plant, and those which are neutral.
So how much of a sort of a complement are they? And not just in terms of, obviously, they're able to be put into one package, but what about from a, when we go the 1 + 1 = 3 scenario, where you've got good genetics, you've got a good seed treatment and a very good inoculant or biological, and the power that has as a package.
Yes, exactly. I think that one of the things that's, for all of us in the industry, it's impossible to predict is, what are the growing season going to be like? What's the forthcoming growing season going to be like? And so in a sense, we have to anticipate that. If everything was perfect, I guess we wouldn't need fungicides and insecticides and biologicals. But things are never perfect. When we grow our crops, when we grow our plants, what we're trying to do is to give them the best chance to reach their yield potential. And all of those elements that I've discussed, the crop protection chemistry, and increasingly the biologicals, are there to help them reach that full crop potential.
And I guess as we look at the history of biologicals, really it looks like a very, very bright future.
Yes.
And so does a lot of that have to do with the environmental characteristics, or what's really driving this potential?
Well, what's driving it really is innovation, because we've known in fact, I guess since we've been cultivating plants, we've known of the interaction, the importance of interaction between that plant and its biologicals. We've never really been able to harness the power of those biologicals, because we're operating in such complex systems. We're talking about things that are going on in the soil, under the crop plant. And that's a difficult environment for us to understand and be able to, if you like, predict and manipulate what happens under there. But with the recent advances in technologies, we are beginning to understand those complex interactions. And once we understand them, then we can utilize them to increase crop yield.
So when we look at biologicals, what are some of the there's obviously in any sort of, when we look at the biologicals, when we are innovating, usually there's some hindrances or some things that sort of hold back that innovation. What are some of the challenges with biologicals?
Well, the first thing is that they are living organisms. They require oxygen, and largely for a large part of their life, they require water as well, same as you and I. And so one of the biggest challenges with commercializing these biologicals is to make sure that you can keep them alive, both in the pack and then on the seed. And then when they go into the ground, you have the right number of viable biologicals to do their job, to do what you expect them to do. That's quite a limitation. The other thing that we've got to be very cognizant about is that the industry will not change to accommodate our products. So our products have to be robust enough to go through seed treatment, commercial or retail seed treatment plants. They've got to be able to survive that. They've got to be compatible with whatever else you're putting on the seed, crop protection chemicals, for instance. And in our case, in biostacked products, they've got to be compatible with each other. So all of those things need to be in place for these products to be commercially viable.
There's obviously a much more of a larger focus on things like beneficials and, you know, not necessarily broad spectrum control, but more maybe targeted. And isn't that kind of the wheelhouse of a lot of biologicals?
Yeah, I mean, that's a really important point, that as an individual organism, biologicals are very specific. When a biological interacts with a plant, it's very specific in its interaction with the plant. However, we want to develop products which are very robust and work across many different soil types, many different climatic regions, many different types of growing conditions. So our solution to that is to put together combinations of biologicals, and then with that combination you get a much more consistent response and a measurable yield response. And of course, once you can measure yield increases, then you can price the product and you can sell on a value basis.